Okay, in this session, I'm going to do R101 basic R using an example data set, a hot dog data set. So this data set is from the book Introduction to the Practice of Statistics by Moore, David, and McCabe. So there are 54 hot dog samples in this case, and different types of hot dogs, be for meat or poultry, and the calories and sodium, milligrams sodium per hot dog are measured on these samples. Okay, so in R you can read data from a CSV file, or if you have a R file, you can directly read that. And in this example, I have embedded the data in the R code itself. So I'm typing, I've typed the data right here, okay? So if you look at the command here, I'm defining an object called hot dog. That's on the left-hand side. And then equals, in R, instead of equals, we put less than symbol and dash. And on the right-hand side, we are using the structure function. Structure, it's a data structure. And the data structure is a list of things, and the first variable is type, so that's a type of hot dog, and then the second variable is calories, and third variable is sodium, okay? And then the names of these variables, I can call them something different, but in this case I'm going to call them type, calories, and sodium. And if I have row names, if I want to have like an ID or something, I could put the row names. But here, I don't have any row names. And the class equals data frame, that means that the object I'm creating is actually a data frame. Okay, data set or a data frame. So let me run this. So I'm going to highlight this and hit run button here. And what I'm doing here is RStudio. I'm hoping you have already downloaded R, and this RStudio, it's a user interface. So when I run that, then the code is on this window, top left window. On the top right window, when I ran the code, it actually read the data. So it says that hot dog is 54 observations, 3 variables. Then in the bottom console window here, that's like a log window in SAS. It'll provide you the output and tells you what's going on. And then on the bottom right-hand side window, that's where the graphs will pop up, okay? So far, we have read the data, okay? So now here, if I type the hot dog, that's the object I have created. Then on the console window, you see the result. So it's actually hot dog. It's a data frame. So it's actually, it's a data, the 3 columns, type, calories, sodium. The data is printed on the screen here. So then the first sample, it's a beef hot dog, 186 calories and 495 milligrams of sodium, right? So there are 54 rows here, 54 samples of hot dogs. So now when you have a large data set, you don't want to print it on the screen. So millions of rows, then you want to have a summary information. You want to understand the structure of the data. So then in R, the structure of the data, you can just say structure, a function you can use, str hot dog. When you do that, so then it says that it is a hot dog is a data frame and 54 observations and 3 variables. And there are 3 columns or 3 variables, type, calories, sodium, okay? Then the type is a character variable, and then it shows you the first few values. Then the calories is a numeric variable, and it shows you some the first few values. And sodium is again a numeric variable. It shows you again the first few values, okay? So then the dollar symbol, what that means is that the hot dog is the data frame, that's a parent. Then the child is the type, calories, sodium, the 3 columns. So then the dollar symbol, that's the delimiter that used in order to understand the children of the parent, right? So I will refer the type as hot dog $sign type, and then hot dog calories, hot dog sodium. That represents these three columns, okay? But if you are used to look at the data like an Excel spreadsheet, like the rows and columns, then you can actually run the head command. Head dog means that, hot dog means that it's going to show you the top 6 rows of this hot dog file, okay? So these are the top 6. We already saw the first one, beef, 186 calories, 495 sodium. We saw that before. So it shows you the top 6. And then tail hot dog, if you run that command, it shows you the bottom 6 rows of the data set. Then if you want to look at the summary of the data set, then you can actually run the summary command. And then it shows you then the type variable have got 54 values, and calories, it's showing you the minimum value 86, maximum value 195, and in between it gives you some statistics. So you very quickly, you understand the range goes from 86 to 195 calories with the mean being 145. Then for the sodium, it goes from minimum of 144 milligrams to a maximum of 645 milligrams, with the mean being 424 milligrams, okay? So let's say that I want to summarize only the numeric variables, columns 2 and 3. So then I can actually run this command. I am saying that summary hot dog only 2 to 3, so columns 2 to 3. So you can actually see the same summary statistics for just the 2 variables we have chosen. And in R, you can do the same things a lot of different ways. So for example, I can use different kind of functions in order to get these summary statistics. And up to this point, I was using base R package. Now there are thousands of packages on R, and each one has got a lot of different functions. So then, for example, here I'm using HMISC, that's another package. And the first I install the package. Then now I want to use the package in this program. So then you should have installed that under the tools. You should install the package first. And then you can actually use the library command to include that here. And then in that, the function I'm using is describe, okay? So when I use the describe function for the hot dog, again, columns 2 and 3. So now you see that this is a slightly different summary information. And for calories, it shows you the number of observations, and then the mean value, and then the percentiles. And also gives you the lowest 5 possible lowest value, 5 lowest values and 5 highest values in this data set. So very quickly, if there are any outliers or something, you'll be able to see it. And similar kind of information on sodium you are able to see here. So there is another package called PastText, and so let's say that I use that package, and then stat.description, and that's the function I'm using. So if I use that function for the columns 2 and 3, again, it gives you the number of values, and then it gives you minimum value, maximum value, range, sum, median, mean, a whole bunch of statistics like that, okay? And then there's another package called psych, and so let's say that I'm using that package here. And in this case, just I want to explain something. I am using the function describe by. Again, I'm using these 2 columns. And then here I'm saying hot dog $type. So here it's a 2-step name I'm using. So what this means is that I want to describe the columns 2 and 3 of hot dog. I want to use the type as a by variable, okay? So now you are able to see here the result of that. So it's breaking down the data into 3 types of hot dogs. So first is beef. There are 20 observations for beef. And then the mean calorie is 156 and mean sodium is 401. And then there are other summary statistics you're able to see here. And then for meat, there are 17 observations. Mean calorie 158, mean sodium 418, and then you've got other summary statistics. And the two means are similar for the meat and the beef. And then for poultry, there are 17 observations, and then the mean calorie 118 and mean sodium is 459. So you see that for poultry, mean calories are lower, but then the mean sodium is higher. Okay, so very quickly you are able to see the patterns in the data. So now I don't want to keep typing this two-step name. So then if I don't want to do that, then I can actually do the attach command. Attach hot dog means that I'm attaching the file hot dog. So from this point onwards, all the variables I'm using are from this hot dog data frame. Okay. So then I don't need to use the two-step name anymore. I can just use the column names. So for example here, I can use the describe by function I used before. Calories and then by type, so the by variable type. So now you are able to see that for beef, you are able to see all the summary statistics for the beef and then meat and poultry for calories. Similarly, describe by command I can use for sodium by type again. So again, it's broken down by beef, meat, poultry, and then you are able to see all these summary statistics here. Okay. And there is yet another way to look at this, to compute the summary statistics. So the apply command usually is very useful in computing summary statistics. So here, again, I'm using the apply command for calories. Then again, the by variable is type, and then the summary statistics. So here again, by beef and meat and poultry for calories, you are able to see the mean, first quartile, median, mean, third quartile, maximum, all those statistics. And similarly, I'm running the same thing for sodium. Again, you are able to see the same statistics for sodium. Okay. So in summary, what we have done so far is using different packages, different functions to summarize the data, and all the summaries have been in tabular format. Okay. So now we want to summarize the data in a graphical format. Okay. So, I'm going to first use the histogram command. So the function is called hist. So histogram calories, so you are able to see the histogram. It goes between 80 and 200. The maximum frequency happens between 140 and 160 calories, right? You are able to see that. So similarly, we can run the histogram command for sodium. Again, you are able to see the range 100 to 700 and the maximum frequency happening between 300 and 400 milligrams. So now I want to break down the histogram by the type of hot dog. Okay. So then I'm including the library called lattice. Then in that I want to do the histogram by the hot dog type. Okay. So the by variable is type, and then now you are able to see the beef and meat and poultry histogram, and you are able to see that beef goes from 100 to 200, and meat also goes from 100 to 200. You see the scale up at the top, and on the poultry goes from 80 to 160. So very quickly, what we saw in the summary information, you are able to see that visually here, the calories for poultry are lower, but for beef and meat, it's higher. You are able to see that. Okay. So then let's do the same thing for sodium, and you are able to see that for beef it goes from 200 to 600, for meat it goes from 100 to 500, but poultry is 400, 700. So you're able to see that the sodium is higher for poultry compared to beef and meat. Okay. So there is another way to plot this information, and that's a box plot. So I'm doing the box plot here, so this has got a beef and meat and poultry. Very quickly you are able to see the middle boxes or higher for beef and meat, but lower for poultry. And the mean value, the thick line here, the mean value for beef and meat higher, but for poultry lower calories. This is what we saw in the summary information. Now you are able to visually see the whole distribution of the values for each one of these categories. Okay. So then this is for sodium. Again, you are able to see the whole distribution of sodium for all the three groups. And you are able to see that poultry is slightly higher in terms of sodium compared to beef and meat. Okay. So far we have done univariate analysis. We just took one variable at a time, sodium or the calories, and we did the tabular form summary, and then we did the histograms and box plot. So now let's look at a bivariate plot so we can do two variable kind of analysis. So we are going to do a very simple thing here. We are doing a scatter plot of calories versus sodium. And then we are distinguishing them by the type of hot dog. So you are able to see here the pattern. P stands for the poultry here. So all the P, the poultry values are down here. High sodium on the low end of calories, but high end of the sodium, you are able to see that. But then up above, the meat and the beef here, so you've got you are able to see that the meat and beef are the high on calories and then medium on the sodium, right? So you are able to see the pattern in the bivariate analysis here, okay? So this hopefully this gave you an idea about how R works in very, very simple case. And if you want to actually mimic this, I have this code on my website. You can download it and then you can run the code yourself to look at the results. Okay?